Good evening, everybody. So I'm Munees, working for ATREE. We are a kind of non-profit organization, mostly working on environmental conservation, sustainable development, and climate change. So this is one of the ongoing projects in my lab. I would like to share some outcomes and problems about this project. Forest habitat assessment for Kalakad Mundanthurai Tiger Reserve. This is one of the important tiger reserve in India. It's situated in the southern tip of the India. It's one of the World Heritage Site. It's having high plant endemism. Most importantly, it's receiving 2 monsoons per year in the Western Ghats. So its biodiversity richness is really important. There are a lot of conservation projects are going on. Several studies already done on forest change analysis and vegetation penology studies. But when we are talking about conservation, it's not just about gain and loss. It's not just about studying the NDVI series or change analysis over the years. But it's also about the species composition, the diversity, and the complexness. So that is the main reason behind this research. This is one of the main problem what we are facing mainly in the tropical forest. Of course, cloud curves are the biggest nightmare in the optical remote sensing. So this is 1 year time lapse of Sentinel-2, which is taken from 2016 and 17. So you could see that, So you could see that cloud cover, it's everywhere and every time. Secondly, another important problem is spectral unseparability. So when we are talking about medium resolution satellite image, it's really hard to differentiate different forests by a single date image. But if you are aware of that seasonal changes like the vegetation penology, it can help us to differentiate different forests. For example, if you see the bottom blue line that represents dry deciduous forest, so this spectral curve is representing the actual reflectance of Sentinel on September and October. So it is almost in the bottom of the graph. If you see that it's in the February 2017, it's going above the graph. So that changes in the spectral reflectance can help us to differentiate different forests even by the medium resolution satellite data. So this is really important for us to study the composition and vegetation type. We find Google Earth Engine is a perfect tool for us because here removing the cloud cover is pretty simple and easy. So we used that to create cloud-free composites for 2 different dates. And second important thing is like multi-temporal and multi-spectral data. So making the composition is really easy even for a large area too. So we added 2 images from September-October combination and February 2. We got a result of 74% overall accuracy. So when we tried with a single image, we just got 63%. For this complex landscape, this is a pretty good deal for us. So based on that forest cover map or forest habitat map, we made some interesting analysis for different species. This is for elephant habitat suitability analysis. So there the forest type is the primary data for this analysis. We used analytical hierarchy process. Aside from the forest type, we used elevation, slope, water bodies, and distance to the water bodies. So yeah, we got the result. We are hoping to apply this same method on different species too. Thank you.